G'day and welcome to another one of my videos. This time I'm going to have a look at sketching some quadratic functions which end up being parabolas of the form y equals x minus something all squared. So we're still going to end up with parabolas. Later on in the video you'll see my face disappear because it'll just get in the way of some of the examples we'll do. So let's start to get through it. So again, we're going to start by looking at the most basic of the quadratic equations. So y equals x squared, and we've gone through how to sketch those quickly with a table of values and what it looks like. And so there's our table of values. Being careful, plot our points on a Cartesian plane, especially being careful substituting in these negative values in here and squaring them. Make sure we get a positive result. And so if we do all the values, our y equals x squared looks like that. So now let's see what happens when we've got y equals, in a pair of grouping symbols or brackets, x minus 2 all squared. So we're subtracting 2 from our x value first before we square the answer. So make sure we are being careful in doing that. And so if we substitute it in x equals negative 3, we can do it on our calculator doing some substitution. So negative 3 take away 2 is negative 5. And now squaring negative 5, we get positive 25. Negative 2 take away 2 is negative 4. And squaring that, we get 16. So again, be very careful with negatives and making sure that you know how to do that on the calculator correctly. Though you should be able to do them in your head too. So, notice that when x is 2, okay, when we get this x value of 2, it makes this part inside the grouping symbols or inside the brackets there 0. So 2 minus 2 is 0. That does help us with some things later on. So we can actually see that our numbers decreasing, get 0, and then they start to increase again. Well, we could actually make our table of values longer to better see the symmetry that's actually involved with our parabola. Okay, and with the aid of our program Algebra, we've actually sketched it, and what we can see is that the parabola stays with its vertex along the x-axis, but has actually moved across 2. So this is our original y equals x squared, and this is now x minus 2 all squared. So we can see that the parabola has actually shifted along, or translated along the x-axis, to the point x equals 2. So it looks like this value of 2 here is being very important and telling us that it's moved across 2 places there. Even though this looks like it's a negative 2 in there, it's this x value in here that makes this 0. That's the important part, and we'll see that with a couple more examples. You'll still notice now that we can read off the coordinates of our vertex, excuse me, which is across 2 up 0. So that's what our coordinates of the vertex are now saying there. So the vertex has been moved 2 in the positive direction. And that's our value of h, okay? So remember, it's x minus h all squared. Our h value is 2, okay, which makes all of that 0 when you substitute in x for that h value. Okay, so let's try another one. Y equals x minus 5 squared. So again, we can just quickly look through a table of values, and I've just extended it along so you can actually start to see some symmetry there, because otherwise if we only went from negative 3 to 3, we wouldn't see much. We just see that they're going down, but they decrease in their value that they're going down in each time. So I've extended it so you can start to see that, yes, this x value, when x is 5, so 5 minus 5 gives us 0. That's going to help us with our vertex, and then we can start to see that the values increase there. So let's sketch it. So this is y equals x squared, and this is y equals x minus 5 all squared. So the vertex is now being moved across to the point 50 in the positive direction. Okay, so it's been moved across 5 units, this h value, and the vertex now, as we said, has coordinates 50. So what happens if h is negative? Well, let's have a look. We're going to do an example when h is negative 1. So all we've done is substituted in negative 1 into here. So we've got negative 1, and take away a negative becomes a positive, so two negatives make a positive. You remember that old rule. So it actually looks like x plus 1 all squared in there. So again, if we completed a table of values and sketched it, so I'm not going to bother doing it this time, and we used our program here, and we can see that this h value of negative 1 means that we've moved the function to the left 1, so across, so that the vertex is now at negative 1, 0. So remember, whatever x value makes this 0, so negative 1 plus 1 would be 0, alright, actually tells us or helps us with our vertex there. So we've been moved to the 1 in the negative direction, so to the left. Our h value is negative 1, and so the coordinates of our vertex are negative 1, 0. So that's quite useful to actually know. Okay, so again, just saying here that it may not be obvious at first, but the x value that makes the term inside the grouping symbols equal to 0 is the actual h value. Alright, so we've been saying that as we've been working through there. So we're going to have a look at some examples now, but before I actually do that, I might actually show you the GeoGebra program and actually have a look here what's actually going to be happening. Now up here in the left hand corner is actually the expanded version of the quadratic, and we'll have a look at how we can go in a later video, how we can actually go from that expanded part into the factored form to make it a bit easier to see. But let's have a look at what happens when we change our value inside. So this is y equals x squared, and then if I do x minus 1 all squared, so x minus 1 all squared, the parabola is shifted across to the 1. And again, up in that top left-hand corner is just the expanded version of the bracket. So all it does is it shifts the parabola left and right, depending on whether the h value is actually positive or negative. Okay, so that's very useful to actually know. So what we'll do now is have a look at some examples. So let's have a look at sketching y equals x plus 3 all squared. And just so you can see it all, I'll just take my picture away here so that it's easier to actually see. So in fact, I might move it up here. You know that this is x minus h all squared there. So when x is negative 3, the value inside the grouping symbols is 0. So that's important to know. So negative 3 plus 3 is 0. So that means now the coordinates of the vertex should be at negative 3, 0. And when we go, there's our y equals x squared. Okay, that's our basic one. And we're actually going to sketch y equals x plus 3 all squared, and it's just shifted across to the left so that our vertex is at negative 3, 0. As simple as that. Okay, so all it's done is moved it across to the left to negative 3, because negative 3 plus 3 equals 0 inside our brackets there. Another point that's important to know is the actual y-intercept. So where this curve now actually cuts the y-axis. So here's our y-axis, and you'll notice that it cuts it up here at 9. and that occurs when the x value, here's my x value, alright, my x value is 0 along the y-axis. So if I substitute in 0 into the equation here, 0 plus 3 is 3, and then 3 squared gives us 9, which is that value in there. So substituting in x equals 0 into a function will actually tell you where it cuts the y-axis, if it cuts it at all. Okay, so we just went through that part there. So the y-intercept is at 9. So let's have a look at a more difficult one. Here we're going to put in a few things together now that we've learned in the last couple of videos. So here's my x minus 1 all squared, and then I'm going to change the dilation, so multiply by a number out the front, and then I'm going to shift it up 4 units. Okay, so we're going to do this in a couple of steps. Alright, so consider the grouping symbols first, x minus 1. Well, when x is 1, the value of the grouping symbols is 0. So what that does is it moves the parabola to the right one in the positive direction, because when x is 1, that makes that 0. So my h value is positive 1 there. That's where my new vertex is. Okay. Now that we know that, the value multiplying the grouping symbols is negative 2, which means the parabola is concave down. So you'll notice my diagram is going to change a fair bit now. So there's y equals x squared. That's x minus 1 all squared. And now this is negative x minus 1 all squared. We haven't multiplied it by the 2 yet, so that's going to change the dilation. Okay, so that's negative 2 times x minus 1 all squared. Alright, and now what we need to do is consider this plus 4, which is now going to move the whole thing up 4. Okay, so that's negative 2 times x minus 1 all squared. Now we've added our 4, which just moves it up 4. So just combining a few things that we've done so far, and it makes sketching so much easier. Okay, this time you'll notice now that the coordinates of the vertex are across 1, up 4. So they were 1, 0, but we've shifted it up 4, so it's across 1, up 4. Okay, if I wanted to find the y-intercept, then I substitute in x is 0 in here. 0 take away 1 is negative 1. Square it is positive 1. Multiply it by negative 2. So positive 1 times negative 2 is negative 2. And plus 4 gives me positive 2. So my y-intercept now is at positive 2, which you can see there clearly on the graph. Okay, so what you now need to do is, again, to practice, and practice some more, especially with some variations in there, and you'll certainly find that sketching quadratics and ending up with parabolas is so much easier than you actually thought to start off with. But if you really get stuck, you could do a table of values, but sometimes you might need to do a fairly big table of values to help you. So, thanks for watching, and again, I hope you found that useful.